Assalamualaikum warahmatullahi wabarakatuh. This is my individual assignment, English for Biology. Before I started my presentation, let me introduce myself. My name is Ika Sulistiawati. My student ID number is 22034160467 offering B 20 and 22.
First, journal identity. The title of the journal is Root Morphological and Anatomical Response to Increasing Phosphorus Concentration of Field Plants Grown Under Salinity. And the journal is Plant Stress. And the authors are Aisyah Laudari, Asmai Mayane, Rashida Nashiri, Yosef Zero, Gile Colinet, and Abdullah Aukarum.
The next slide is research question. How the root morphological and anatomical responses to increasing phosphorus concentration of field plants grow under salinity. The next slide is background. Plants alleviate the negative consequences of abiotic stress by adopting physiological, morphological, and metabolic changes and by developing an adaptive state. The root-soil interface has been subject to many studies on the adaptive process of plants to different stress conditions. Root features are known to be influenced by the availability of mineral elements, water, and other physiochemical characteristics of soil, and their interaction in the plant's rhizosphere. Root architecture changes depending on the availability of nutrients, and most studies on root morphology and functioning in plant nutrition concern the relationship between root features and phosphorus. The ability of the plant to intercept immobile nutrients such as phosphorus by developing new root architecture is considered to a plasticity adaptation of the plants to ensure sufficient growth and development.
Root performance to acquire water and nutrients
Depends on root features, including the number and diameter of xylem vessels, width of the root cortex, root exodermis, and endodermis.
For instance, in salt-stressed plant, roots are the first sensor to detect an excess of natrium and chloride. This salt-stressed condition induces a series of adaptive plant responses in root morphology and anatomy, as well as in root features.
Root morphology changes in salt-stressed plants have been intensively studied and results are agreed that root morphology readapted to ensure efficient water absorption and nutrients uptake, abundant and efficient water nutrients translocation to leaves. Disordered nutrient uptake in a plant grown in saline conditions has been investigated in different plant species and salinity degrees, and there's evidence that salt stress leads to nutrient deficiency that influence spatial root architecture. Root length, surface, diameters, and other root parameters change depending on salinity degree and plant species. Root anatomy is also considered a valuable parameter to be considered in understanding how the root system controls soil salinity effect on plant growth. Root anatomy determines root performance and efficiency to acquire water and nutrients and their transport to be above ground organs. Furthermore, salt stress induces a series of modifications at the root anatomical levels, such as a decrease in cell expansions, perturbed cell division, and root elongations, as well as a reduction in root meristem size.
Understanding the role of nutrients in the alleviation of salt stress effect and the unrevealed significance of root system architecture for plants adaptation is one of the major research axes in the actual context of agriculture. To cope with the constraint of the low availability of phosphorus and enhance crop productivity, there is an urgent need to focus on the reasonable application of phosphorus sources which are more efficient. Polyphosphates have been used in agriculture and are well known for their continuously and slow release of available phosphorus to plants in agricultural soil. These qualities make a polyphosphate a sustainable source of phosphorus to meet plant needs and reduce phosphorus losses over time in soils. Additionally, it has also been reported that polyphosphate fertilizers differ from orthophosphate by their ability to select some micronutrients like manganese, iron, and zinc. Compared to orthophosphates, the plant response to polyphosphates application under saline conditions is not widely studied. Hence, the journal study hypothesizes that the use of polyphosphates at different phosphorus rates could result in a positive effect on root growth and specifically the development of roots, which is crucial for plant nutrients acquisition, especially phosphorus. Hence, this study was planned to investigate the effect of salinity stress on root morphology and anatomy, as well as nutrient uptake of wild plants with special emphasis on how polyphosphate and phosphorus doses alter root morphology and their anatomy under salt stress.
The next slide is methodology. Time 18 September 2022. Place a shaded house under open field condition at the experimental farm of Mohammed VI Polytechnic University, Ben Guairer, Morocco. Targets are root biomass, root and rhizosphere mineral content, root morphology, root anatomy, and root phosphorus acquisition efficiency. And the method is experiment. The next slide is result. First, root biomass. Shoot and root triweek decline significantly in unfertilized plants grown under salinity compared to fertilized ones. Second, root and rhizosphere mineral content. The available phosphorus in the soil and its acquisition by roots significantly increased according to the phosphorus doses, which was among the expected result. Next, root morphology. Fertilized plants presented significantly responses compared to control and unfertilized salt-stressed ones. Next, root anatomy. Phosphorus fertilized could enhance salinity tolerance and potentially improve the water uptake capacity by increasing stem diameters, which will promote deeper rooting. And the next one is root phosphorus acquisition efficiency. Show a significant increase the RPAE of fertilized plant compared to unfertilized plant, exposed to salinity or not. The next slide is discussions, showing that phosphorus is an important factor in the growth of shoots and roots, and low phosphorus uptake under salinity may reduce biomass development. To minimize the negative effect of salt stress, the plant developed phenotypic plasticity. The next slide is conclusions. This journal focuses on different root responses of wild plants grow under the combined effect of salinity and phosphorus availability using different doses and forms of phosphorus fertilizers, and show that salt stress induces at both anatomical and morphological levels a series of modifications in the roots of its plants. That's all of my presentation. Thank you for your attentions. I hope my presentation can be useful for all of you guys, and I hope you have a happy day. See you in the next video. Wassalamualaikum warahmatullahi wabarakatuh.